work is something that's extremely important in physics, and I'm just going to define it here like this. Essentially, here you can see I have a couple of drawings here. Work is equal to the force parallel times distance. Parallel meaning that we're going to have to use a cosine theta. I give a little picture here of an object which essentially shows that this object is going to move some displacement to the right. And here are my forces: my force applied, my force normal, force of friction, and force of gravity. Well, if this object gets moved to the right, what it means is that this force applied is actually in the same direction as the displacement. They're in the same direction, which means that my theta here would be 0 degrees, and that would equal cosine of 0, which is 1. In which case I would be doing, this would be doing positive work. Okay, the force applied does positive work. What about force of gravity? Well, force of gravity here would be doing negative, or actually 0 work, because it's perpendicular to the displacement. Because it's perpendicular, this does 0 work. Okay, similarly, force normal would also do 0 work. Force of friction is 180, and I do this little thing here to say, well, here's my force of friction, there's my displacement. They're 180 to each other, and the cosine of 180 is -1, which is why this does negative work. Okay, so while this does negative work, positive work, and 0 work all in one. You can apply this to many scenarios. You can apply this to inclined planes. And an inclined plane example would be, well, if I drew my inclined plane here, had a little mass. Let's suppose that this object moves with some displacement down the ramp. Okay, what forces are acting on it? Well, there's going to be a force of gravity. There's going to be a force of friction. And there's going to be a force normal. Now, of these forces, what does work? Well, gravity in this case, unlike the other one, actually does do work. And in fact, it'll do positive work. Because my force of gravity points down this way, but here's my displacement. Now, there is an angle between them. It is not 90. And so, in fact, this will give you, because it's less than 90, it's some positive cosine value, which means it will do some positive work. Force of friction still acts 180 to the direction of motion. And so this will actually do negative work. This will do positive work. And this will actually still do 0 work, force normal, because it's 90 degrees. But you can look at examples like this. In terms of the unit, well, work is equal to force times distance. And again, that's a Newton meter, which we abbreviate as a joule. Okay, capital J for a joule. One last thing to take note of is in terms of graphing. If I have a graph, and let's say that this is a force distance graph, and you know, whatever the shape of the graph looks like, okay, it could look like that. Here's some force distance graph. The area under any given part, okay, let's say right here, I want to find out what this area is. Well, this area, that equals the work done by this force. The reason being is because to find this area, I'm going to have to say F times D. And we all know that force times distance is your work. So the area underneath any graph will be your work. You can have positive work. You can have negative work depending on the area that you're looking at. Okay, if it's below the axis or above, positive work or negative.